Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Today we're at Blake School and we're here to Well, today we're at Blake School. We've got students in 6th, 7th, and 8th grade. You guys ready to go? Yeah. All right. So the first thing is we're going to talk about place value. Now you guys know about place value already, right? What can you tell me about place value? Do you know any of the place value names?
There's ones, tens, hundreds.
Right, there's ones, tens, hundreds, thousands, 10,000, stuff like that, right? What about the other side of the decimal?
Tenths, hundredths, thousands.
Right. So that TH at the end of that, right? Tenths, right? Because you're talking about a fractional part of a whole number, okay? So take a look at the paper you guys have in front of you. And there's a number that is underlined in each of those, all right? So what it says is, in what place is the underlined digit? All right, so look at the first one. We have 276,753. Obviously, what is the number that is underlined? 7. And what place value is that?
100.
It's in the hundreds. All right. So just take a look real quick and see if you can identify the place values for all of these. All right. Should take you about 10 seconds, right? So you don't have to actually write down what they are. As long as you look at it, you go to the 7, that's the hundreds. The 1, what's in that? The one underneath it? That's in hundreds, right? Okay. So let's go to the very bottom one on the left-hand side. All right, so can you read that number?
428,137.
Okay, and what number's underlined?
7.
And what place value is that?
Ones.
The ones, right? So here's what we're gonna do. You're gonna roll the die one time, okay? Each of you is gonna roll it. We're gonna make one large number, okay? So whenever you roll it, you're going to write down that number, and then the next person rolls it, we're going to write the number right next to it, okay? And then the next person rolls it, we're going to write that number. You guys got the idea? So you're all going to have the same number written down at the end of doing this. Now, if there are 6 of you, how big is this number going to get? To what place value?
The 100,000.
The 100,000s, all right? So you can go first, roll it, whatever it is, let everybody else know. All right, so on your papers, doesn't matter. You can do it on this side of the paper, the back side, anywhere you want. So 6 is the first digit. All right, take the die, roll it around. Next one up. Just go ahead and pass it down. All even numbers so far, 6, 2, 4. All right, another 6. And ends with a 2. So, what is the number? Riley, what have you got?
624,652.
You guys all agree?
Yes.
All right. So you've got 624,652. What I'd like you to do is take the number in the tens place and round that number to the nearest tens. So take that whole number you had, 624,000, whatever it was, and round it to the nearest tens. So what's the first thing you're thinking of? What number do you have to look at, first of all?
The 5.
The 5, right? The number in the tens place. Now, if you want to round it to the tens place, what number do you have to look at next?
2.
The 2, the one to the right of it. Okay? So is that 2 going to do anything to the 5?
No.
Why not?
Because it's below 5.
Right, it's got to be below 5, right? Okay. So what is the new number now if we rounded it to the nearest 10?
624,650.
Right, 650, because you were going 650 right at the beginning there, all right? So underline the 4. Now round that number to the nearest 1,000. So you want to take that whole number, 624,658, whatever we had, or 52, right, and round it to the nearest 1,000. So the number in the thousands place was the what?
The
4. The number next to it is what?
6.
So what's that going to do?
Make it bigger. Make it
It's going to make it larger, right? So go ahead and write down what that larger number would be now. So instead of 624,000, it's going to be what?
625.
625,000. Remember, everything else becomes zeros at the end of that, right? Because you're rounding. And that's the first step with the students at Blake School. And we're back at Blake School with students from 6th, 7th, and 8th grade. So we talked about rounding numbers last time, place value, and things like that. Now we're going to talk about number patterns. What are any number patterns that you can think of? So patterns where it follows. So if I go 2, 4, 6, 8, what am I doing?
You're following the same number each time. You add 2 to each number.
Right, I'm just adding 2, right? It's a number pattern. I'm adding 2. They're also even numbers, right? 2, 4, 6, 8. What are some other patterns?
3, 6, 9, 12, 15.
There you go. It's just like multiplication tables, right? Those are all patterns. What are some other patterns that aren't so simple or easy? Can you think of any patterns that would be a little bit different?
1, 2, 4, 8, 16, 32.
There you go. Perfect. And what are you doing with that pattern? So go ahead, say it again. You guys write this down. So say your pattern again. So if you started off with 1.
1, 2, 4, 8, 16.
Okay, so stop there. So you have 1, 2, 4, 8, 16. Now that's a little different, isn't it?
Because you're doubling it each time.
You're doubling it each time, right?
We're multiplying it by 2.
Multiplying it by 2, right? Taking whatever the previous number was, multiplying it by 2. How about this one? See if you guys have ever heard of this pattern. Go ahead and write this down. We'll go 1, 4, 9, 16. Do you have any idea what that pattern might be?
Dividing maybe? I don't know.
Because the numbers are increasing in size as we go. What kind of pattern do you see? So we went from 1 to 4. You could either say,
3, 5, 7, and it's all odd numbers.
okay, so they're increasing first by 3, then by 5, then by 7. So what would the next one be increased by?
By 9.
By 9. So add 9 to the last number and see what you get. So you have 16 and you add 9, what do you have?
25.
25. Have you heard of square numbers? Where if you have an exponent to the second power, right? If you have 1 squared, that means 1 times 1, right? What's 2 squared?
4,
4. What's 3 squared?
9,
What's 4 squared?
16,
Do you see what those numbers are? They're the same numbers, right? So what's 5 squared? 5 times 5? 25, right? So those are square numbers, all right? So what I'd like you to do is, on your paper, come up with 4 numbers, okay? Make a pattern. It can be any kind of pattern you want, but don't do like 2, 4, 6, 8, right? Or 1, 3, 5, 7, because those are easy patterns that people can look at really quick, okay? So you think of a pattern. You can start with any number you want, and then you could go like, all right, well, I'm going to take this number and I'm going to divide by 2 and add 2. and then I'm going to take the next number, I'm going to divide that by 2 and add 2. You guys see what I'm saying? Try to make kind of an unusual pattern. All right, go. Who has 2 numbers down so far? You've got 2 numbers? You've got 2 numbers? All right. So let's see if we can figure out. And what's your name again?
Ellie.
Ellie? All right. So Ellie, what are your first 2 numbers?
1 and 8.
1 and 8. So what could possibly be going on? She could be doing what? Could she be adding something?
I'm not, but I could be.
Well, it could be adding 7, right? Or she could be multiplying by 8. So there's 2 different things. Do we know definitely what her pattern is yet? Because it could be 2 different things so far, right? So what's the next number?
I don't have that one yet. Well, my first 2 numbers are 1 and 8. So
Okay.
I have to get my third number.
So you know what your pattern is in your head, what you're trying to do?
Sort of.
All right. So we'll let the kids at Blake School, 6th, 7th, and 8th graders, continue working on their patterns and see what they come up with. And we're back once again at Blake School with students in 6th, 7th, and 8th grade talking about numbers, first of all, place value, and then number patterns. So here on the 100 chart, you can find a lot of different patterns on that 100 chart, right? What's one pattern you might see on there right now?
1, 2, 3, 4, 5.
1, 2, 3, 4, 5, 6, right? Okay. Take a look at going down a column.
2, 12, 22, 32.
So what are they doing?
Adding. They're
They're just adding 10 every time, right? So there's a lot of patterns that you can find on a 100 chart, right? You could look at it diagonally, right? There, you could look at the corners. You could look at just the ends. There's all sorts of different things you could look at and find patterns on that paper. So in each of your pairs, you have somebody's number that you're looking for. And there are 6 clues on that paper. What you need to do is you need to look at all 6 clues and use your 100 chart and see if you can figure out what that person's number was. All right? So you guys have Paul's number, right?
Yes.
What's one clue? Read the first clue on there.
Paul's number is not located on an edge or a corner. Help your group find Paul's number on the 100th.
Okay, so it's not on the edge or a corner, correct? So what numbers can you get rid of if it was your group right now? What would you do with the 100 chart? Yeah, what do you want to do?
You wouldn't have any of the sides.
You would just cross those out, right? You could just draw a line right through the sides and the corners, right? So the 100 charts are for you guys to work on, all right? What about you guys? What's the first clue on yours?
The sum of the digits of Meg's number is greater than 10.
So you know that when you add the 2 numbers together, that number is going to be larger than 10. Now, let's take the first number larger than 10, 11. If we take 1 and 1, what does that add up to?
2.
2. That can't be the number, can it? Because it's not larger than 10, right? What about 23?
That's 5.
That's 5. That can't be it, right? So you know it's not going to be anywhere around there. You're going to have to think a little bit higher on that one.
Any teens except for 19.
Right. So go ahead and keep working, right? It has to be larger than 10, and look at all the clues, all right? What about you girls? What's the first one?
Meg's number is a multiple of 3.
So it's a multiple of 3, right? So if you know your multiples of 3, 3, 6, 9, 12, 15, and you just keep on going, you know it's going to be one of those numbers, right? So if you guys wanted to, you could go like, all right, like circle 3, circle 6, circle 9, 12, right? And then start doing all the clues and condensing them. See if you guys can find out what the number is, all right? Go. You guys think you have the number?
Yes.
Paul's number. What do you think Paul's number is?
29.
What is it?
29.
29? Read the clues and let's see how the clues work out.
It says Paul's number is not located on the edge or corner.
Okay, so 29 satisfies that.
It is not an even number.
29 is not an even number.
The difference of the digits in Paul's number is 3. We didn't look at that one.
So the difference in 29 would be 7. So the number, you're getting close.
We'll have to find a different one. So we gotta think, Dahlia. The difference has to be 3, but the sum has to be 11. Alright?
So the difference is 3 and the sum is 11. Did you guys find your number?
Yeah.
What is it?
84.
Whose number were you looking for?
Meg's number.
Meg is 84. Read the clues quickly.
The sum of the digits of Meg's number is greater than 10. The difference between the two digits of Meg's number is greater than 3. Meg's number is a multiple of 7. The first digit of Meg's number is larger than the second. Meg's number is not odd. Both digits of Meg's number are even.
And 84 satisfies all of those things. Congratulations. Did you guys find your number now?
Yes.
Which number is it?
I think it's 47.
47 is correct. Nicely done. You guys still working on Tim's number or have you got it?
Yeah, we're still.
Still working on it? All right, continue working. We've got the 6th, 7th, and 8th grade students looking at number patterns and figuring out what the number is at Blake School. Once again, we're at Blake School. We have students from 6th, 7th, and 8th grade. We've been working with a lot of numbers, looking at patterns, figuring out what mystery numbers were, place values, and now what we're going to do is we're going to work with decimals. So you know how there were ones, tenths, hundredths, right? So now we're going to have tenths, hundredths, thousandths that we're going to be looking at, okay? Can you all count up to 1?
Yes.
Yes, right? That's the number that we're going to be looking for. The number 1. All right, so take a paper, pass it down. All right, so here's the deal. You may either choose, well, let's just find 1. All right, so what I would like you to do is on your paper, I want you to find the number closest to 1 that you can make. All right, now, how many spaces do you have?
3 on each.
You have 9 altogether, right? Now look at the directions. It says you may use the numbers 1 through 9, each one once. Okay? So, if I just went 1, 2, 3, 4, 5, 6, 7, 8, 9, I could do that. And then you add them up, and you see if you're close to 1. Now, do you think it's going to be that simple?
No.
Probably not. Okay? So you want to get 1.000 if you can. Or if you don't even get to 1, what number would be very close to 1 in a decimal but not 1? Do you guys know?
9. Like 0.9.
0.9, right? Now on here, instead of just 0.9, what would get even closer? Because you need 3 numbers after the decimal. So if you went let's say you added them up, can you get any closer than 0.999? You can't get any closer, can you, to 1? All right? So think about getting to 1 or 0.999 or maybe 995 or try to see if you can come up with 99 something at the end. All right? So go ahead, and what I would do is I would write kind of small in those boxes because you think your first guesses are going to be the right ones? Probably not, right? So that way if you write kind of small, you can go, all right, well, I'm not going to use that here, or if you have an eraser, you can write as large as you want. All right? You can work together if you want. You can work separately. That's why you've all got your own papers. All right? So try to get as close to 1 as you can. Go. So you're almost through filling them in, right? What numbers do you have left? So you use 2, 3, 4, 5, 8, 9. So what do you have left?
I have 1, 7, 6.
Okay, so you have 1, 7, and 6, right? So just go ahead and put them in there because you're going to add them. It doesn't matter what order they go in. So now let's take a look at see what you're at. So you had 9, 5, and 2, and when you added those up, what did you get?
I got 16 and
Right.
15.
Right, so you got 16, you carried the 1, right? 1 and 8 is 9.
Yeah.
9 and 4,
Would be 13,
13 and 3,
15, or 14. Yeah.
13 and 3,
13 and 3 would be 16.
16, right? So just change that to a 6, carry the 1. Now what have you got?
15.
Okay, so, right, so you've got 15, right? So how do you write that now? So you're going to put the 5 there. So you have 1.566. Are you close to 1? You're a little bit over, right? 1.5, right? So we'll let the kids continue seeing how close they can get to the actual number 1, possibly even 999. If possible, they can find that with the 6th, 7th, and 8th grade students at Blake School. There you go, if that's what it is. If that's what it is, that's what it is.
I like the first one better.
Oh my gosh.
It's the first one.